Now, for our wrestlers, we found that the mean is 125.6. Well, what we do is we sketch a normal curve. Okay? Now, remember how we sketch a normal curve? We line off our axis here, and we have a central value up here. We come down to 60% of that value, and that goes over here and over here. We come down to 1/7 of our central value. That's about here and here. And then we sketch a reasonable curve. I never get it right, but that's what the curve looks like on this attempt. Okay? So, what's this? This is your mean. This is your mean plus your standard deviation. I'm going to use this sigma for your standard deviation. And what we have is we have the standard deviation here and here and here and here. So that this number is, well, it's one standard deviation to the left of the mean. It would be x bar minus sigma. This would be another standard deviation, x bar minus 2 sigma. So, that's where this picture comes from. So we want to make this picture for our wrestlers, the weights of our wrestlers. So we calculated x bar, we calculated our standard deviation. So our picture is going to look like this. X bar 125.6 is going to go in the middle, and then our 1.13 is our standard deviation. So this point then will be mean plus standard deviation. That's 125.6 plus 1.13, 126.73. And I'm just going to round it to 126.7. And then we go another 1.13 in this direction. And that's going to be, the 126.73 plus another 1.13. And that's going to be 127.86, which will round off to 127.9. So we'll just kind of put a line through that, and we'll just round it to 127.9. And then to the left, if we go one standard deviation to the left, 1.13 less than this, comes out about 124.5. And then two standard deviations less than this comes out about 123.3. So I've drawn those here. And I've actually gone another standard deviation. So I've got my mean 1, 2, 3 standard deviations to the right, and the mean 1, 2, 3 standard deviations to the left for the purposes of what we're going to do. Now we want to locate the actual numbers, the weights, which are 123 through 128 to the whole pound. We locate those on the graph. So my green points here indicate where each of these numbers would occur. For example, the reason I did the 122.2 here, it's because the 123 is to the left of 123.3, and I want to have that interval from 122.2 to 123.3, and I want to position 123 within that interval. 123 is 3/10 less than 123.3. It's 8/10 more than 122.2. So it's going to be quite a bit closer to this end of this interval than to this one, so I put it right about here. And with each of these numbers, I reasoned out where it would be within the interval between the values that we originally labeled, the values that we get by going to the right 1, 2, and in this case 3 standard deviations, and to the left. Okay, these numbers here. Okay, so I locate these numbers. Then what we do is we construct the histogram based on these numbers. Okay, well, the histogram for 123 will go from 122.5 to 123.5. It'll go from halfway between 122 and 123 to halfway between 123 and 124. So I locate that interval here, and then using the height of the normal curve at my actual 123 point, I draw the bar. Okay? Then for 124, Well, 124 is going to extend from 123.5 to 124.5. That's from here to here, if you look at the scale, because this comes right out on 124.5. And I use the height of the graph at the 124 point, and I draw my bar here. And then I do the same for the other bars. And I get these bars that are the normal approximation of the distribution. Now, the histogram for that distribution actually looked like this. And you would have drawn the histogram. Your histogram would have looked similar to this. Now, does that histogram look similar to the normal model of the histogram? Are there differences? Well, you can see that there are a couple of differences. One is that this bar down here is a lot closer to this one. Okay? The height of this bar is a lot closer to the height of this bar than this one is to this one. Also, this bar, the one to the right of the highest one, is a lot lower than it would be over here. So this isn't a perfect picture of the distribution, but it's not a totally bad picture. That means that the weights of these wrestlers was not really normally distributed, but it was sort of normally distributed, so you can kind of use a normal distribution to answer questions about the wrestler weights. Now, one anomaly with the wrestler weights is simply that 126 is the limit to the weight class. I didn't say that. I didn't state that in the problem. So that most of the wrestlers are going to come out at 126 or less. There are a couple of them that didn't quite make weight. So this distribution we would not expect to be normally distributed around the maximum weight. We would expect wrestlers to have to struggle to lose weight. Once they get down to 126, they stop. They step on the scale, they're 126. Okay? Some of them might just naturally wrestle better at the lower weights, but the weights are going to tend to cluster around 126 on this side, and there are not going to be too many of them on the other side, at least if you have competent weight, wrestlers that are competent at making their weights. You're going to expect things to drop off on this side. So the normal model is not perfect for this situation.